Hi everyone, welcome back. Today we're doing kth distinct string in an array. A distinct string is a string that is present only once in an array. So given an array of strings array and an integer k, return the kth distinct string present in array. And if there are fewer than k distinct strings, return an empty string like this. So note that the strings are considered in the order in which they appear in the array. So order matters in the array. So in this case, we have D, B, C, B, C, A. And we are supposed to return k equals to 2 and we get A. And the only distinct string in array are D and A. D appear first, so it's the first distinct string. A appears second, so it's the second distinct string. So in this case, if B in this case is not a distinct string because it has 2 copies, and C in this case, it has 2 copies as well. For the second example, array is AAA, and A, and we return AAA. All 3 strings are distinct, so first string A is returned. Finally, for example 3, A, B, A. In this case, B is the only distinct string, but you want the distinct string at the third position. So since there are fewer than 3 distinct strings, we return an empty string. There's no distinct string, that is the third distinct string. So we return empty string. So in this case, k and the array length will range from 1 to 1000. And every single item in array, these strings over here, range from length 1 to 5. And every single item in array consists of lowercase English letters. Very interesting question. Okay. It's an implementation detail, but I guess one way we can go through this is by doing a linear scan across array and keep track of each variable inside here. We need a mechanism to keep track of the count of every character that appears in array. So we can do one linear scan across array to get the counts of all characters in the array first. And afterwards, we can keep track of the counts in a dictionary. Afterwards, we can do a linear scan across array again, and we will append only the characters whose counts is equals to 1 into a separate array. And we will use this array to get the kth distinct string. Sounds like a pretty good idea. So let's try defining a dictionary. This dictionary would be of type string to integer, and this, let's give it a better name. Let's call this a character to count, and this will be equals to a dictionary like this. And we will do an iteration across array. For character in array, we will increment the count of this current character to be equals to character to count get char, and if it doesn't exist, we will assign it to 0, and we will just increment this by 1. And after the first iteration in character to array, let's call this distinct chars, and these distinct chars will only contain characters which are distinct. So if char to count get char is equals to 0. So we can just get it by character key, because this will be populated in line 7 to line 8. So the character only always exists in a dictionary. So if this character exists in this dictionary and this count is equals to 1, in other words is distinct, then we will append this with char. And because we're doing a linear scan in array from left to right, the characters that are distinct first in the first part of the array will be guaranteed to be in distinct chars. So in summary, distinct chars is a list and it will contain the distinct characters in order of when they appear. So once we're done with these two linear iterations, then we can just check if this k exists in distinct chars. So if k is more than the length of distinct chars minus 1. So let's say your distinct chars has 5 characters, have 5 strings, then k is currently more than, if k is currently more than the length of distinct chars, so let's say you have 5 and your distinct chars is of length 5, then yes, we do have a distinct character, a distinct string at position k. So this check looks correct if k is more than distinct chars. So let's say you have 6, you're looking for the 6th distinct string, but your distinct chars is only of length 5. In this case, this will be true, and we will just return an empty string like this. So in this case, that is because if there are fewer than k distinct strings, return an empty string. Else, in this case, then we will just return distinct chars at position k minus 1. Because distinct chars is 0 index, so if you want the 5th distinct string, actually I should call this distinct string, should I? Yeah, I should call this yes, this should be a string actually. This is not char to count. This should be string to count, because every single item in array is not just a character, it is also a string. So this should be string to count, get string for string in array, in string to count, string, distinct strings, append string. Yes, and distinct strings. So pardon me, it's just that I given very misleading names to each of these dictionary and list over here. So I'm just correcting them and replacing the chars with strings instead. So this looks fine. Okay, but back to the point, the reason why we use k minus 1 is because if you want the 5th string, 5th distinct string, then the index inside distinct string will be 5 minus 1, because distinct strings is 0 indexed. So this looks fine. Yeah, this looks fine. Let's run through this across one test case. So array is equals to this list, k is equals to 2. String to count is now an empty, I will comment it here because dictionaries can be very long. And distinct strings, I will assign it on a separate, I will trace it on a separate line as well. So string to count equals to this. Actually, yeah, I think it's okay. Yeah, I'll just hash it here, but this is a multi-line string, so this is fine. It's fine for me to not comment it properly. But anyway, let's start tracing. So currently we initialize these two as empty dictionaries and empty lists, and we start to iterate every item in array. So string is now equals to d, and now we set string to count for this string to be equals to string to count dot get d. In this case, d doesn't exist in the dictionary, so this will return 0. And in short, this whole expression over here will evaluate to 1. So string to count for d is equals to 1. So now we continue with b. b doesn't exist, so we would populate b with 1 here. and we will continue C. Similarly, C doesn't exist, so I mean C exists, C doesn't exist at this point, so this is 1. Now we set it to B. We are now at the 4th item. Sorry, let's use this 4th item. So B is now 2, and C, we move on to C, the next item over here. C is now 2, and now we add A as well, and this is equals to 1. So at this point, on line 19 to line 20, we got each of the respective counts of each string inside array. And we're done with line 19 to line 20. We can then start to iterate through all items in array again. String is now equals to D. And now we can see that if string to count is equals to 1, in this case, D is really equals to 1, so it's true. So we will append distinct strings with D. Now we will move on to B. And B in this case is not equals to 1, so we don't append it. Now we see C. C is false as well because it's of count 2. So we will move on. We will see B again. This is false. We will see C again. This is false. And now we see A. And A, because its count is really 1, we will append it here as well. And now K is equals to 2. So K is 2. Length of distinct string is 2. So this is false. We skip line 26 to line 27. On line 28, we are now returning back distinct string as K minus 1. K is equals to 2, 2 minus 1, distinct string at position index 1, we return A. So the answer over here would be A. So is the answer A? Okay, looks good. Okay, so with that, once again, this question is quite simple to reason with. So fortunately, we were lucky to implement it before, during the planning phase. So let's quickly implement this again. We will first initialize string to count to keep track of the count in each string in array. And next we will define distinct strings. This will keep track of all distinct strings in the order of which it was found. So we will do a linear scan in array to count the occurrences of each string. So string to count dot get string 0 plus 1. So in this case, this is just a hack. If the string doesn't exist in the dictionary, we will set it to 0, and we will just plus 1 and assign that inside this dictionary, where string is the key and the count or the current occurrence of that string as the value. Once we're done and we have a good map of how often this string has occurred, then we just do string to count string. We will check whether if the current string occurs only once. If that's the case, we will do distinct strings.append string. So if it is unique, we will append it into distinct strings. And now we check whether if we have enough distinct strings to get the kth string. So let's say if you want the second string and your distinct string only has 1 item, then we'll return an empty string because there is no distinct string at second position. Else, in this case, we will just return distinct strings at k minus 1. And that's the answer. Let's quickly trace this out to see, okay, we initialize the dictionary to keep track of the count. We initialize the list to keep track of all distinct strings in position of how we found it. We do a linear scan across array to get each string. We populated the counts for each string. We use this map to check whether if a string is unique. And we're doing a linear scan again so that we can append the strings in the order of when we found them. Because in this case, the order of when the distinct string appears from left to right in array matters, and we append them in order. So if we do not have enough strings, then we return an empty string. Otherwise, we return the kth distinct strings by getting k minus 1 there. So looks good. Let's run this against the sample test cases. This passes the test case. Let's submit this. And there we go. We got the answer. So in this case, the space complexity over here, we are populating the counts here. So in this case, this dictionary over here will... Actually, let's get the time complexity first. Sorry, I got confused a little for a moment myself. But let's say the length of array, n is the length of array, okay? In this case, the time complexity in this case will be on, because if you have 100 strings, then it will take 100 computations here to keep track of the counts for each string from line 40 to line 41. Then we have another on here. We are checking for every string again, whether if they are distinct. This is going to take on time again. For string access is O1, so all computations here are O1. So in this case, the time complexity is O2n. If you remove the coefficients, it will be On. For space complexity, in this case, we are keeping track of the counts of each string. So in this case, the dictionary in the worst case scenario, if the whole list contains unique strings, then you're going to initialize one key value pair for each string. So this dictionary here will take On. This dictionary here will take On space. I will remove the runtime tracing over here. So this will take On space over here. And distinct strings over here, in the worst case, if your array contains only distinct strings will have the same length as array. So in this case, this will also be another copy. This can be up to On as well. So this is O2n. And there's no other major variables that are scaling linearly with memory. These are just temporary variables to keep track of strings. Yep. So in this case, the space complexity is just O2n. But if we remove the coefficients, it will be On as well. So that's pretty much the answer for this question. If you found this useful, please give us a like and subscribe, and we will see you in the next video.